I always say namaste before my class, so I will continue with that tradition. Okay, so what is machine learning? Anyone? What is machine learning? Okay, those who have taken my course are barred. They know about it. Sorry about it. Yes, anyone else? What is machine learning? Yes. Okay. How to learn patterns on data? Okay. 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 Anyone else? Okay. All of you know programming? Okay, sorry. Now I'll move forward. All of you know programming? Okay. So I'll give you program what is called as programmer friendly definition of ML. Okay. I call this as sorry. Programmer friendly definition of ML. Okay. Task 1. Add two numbers. Can you write a program for this? How do you write this? Def add a comma b return. I'll be surprised if there is someone who doesn't know this. Okay. Clear, right? Now task 2. This is task 1. Task 2 is given a picture. Find whether humans are present in the picture. How many of you can write a program for this? Yes, you can write a program. Yes, how will you write this program? YOLO, okay, that's okay. YOLO is again some library, right? YOLO uses machine learning below, right? But without machine learning, can you write a program? From first principle, you are given a picture. Yes, yes. Anyone else? Can you write a program for the second task? Don't give up. There are always ways of doing it, right? You can write a program. Someone can of course write a program, but it's not very clear whether it will work for all the pictures or not, right? You can write it for specific configuration, let's say front facing pictures, may not work for side facing pictures, right? Or if it is taken from other angle, it may not work, right? So writing this program is hard, correct? So what is the difference between these two tasks is the question. Add two numbers and the second task. What are the differences between these two tasks? What is the main difference? Okay, that is still okay, but fundamental difference.
The first one is mathematical, second one is cognitive.
Path to get the output is not clear.
We don't know the rules
Second one can also be mathematical, but we just don't know the rules.
The first one is very structural.
Yes, 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 same, okay. Yeah, first one has definite mathematical expression, right? Or you can call it as formula, you know the formula, correct? In a layman's term, a plus b, everyone knows, you can code it up and you are done. Second one, we do not have concrete formulas, correct? And that's where all the struggle is, correct? Because there is no concrete formula for doing this, we are not able to write a program that works on all kinds of inputs. See, first one works on all kinds of input, it will give the correct answer all the time, right? But humans are really good at it, right? All of you are good at it, right? Or at the second task. If I show you a picture, you will say that, yeah, whether there is humans present or not. How do you do that? You recognize, right? You have seen so many humans, you have seen pictures of humans, and based on that, your brain has figured out a way of looking at a picture and deciding whether there is a human face there or not. Getting it? Now what we want to do is, we want to replicate exactly the same experience with the machines. Getting it? So the kind of data that was accessible to you, we also want to make it accessible to machines. Are you getting it? If you have questions, please ask, okay? And by the way, how do I scroll down the page? Sorry, I am new to this technology. We'll continue. So how do you do that? We have to bring the experience, right, that is accessible to humans. All right, thanks. So we need to get data, right? What does that data should have? It should have pictures, right? Picture 1, picture 2, and so on. Let's say some n pictures, correct? Along with this, you will also tell whether there is human present or not, which is 1 0 value. Getting it? Value that is 1 and 0, something like this. So this data is what we need to give it to computer. And in technical term, this is called as training data. This is called as training data. So now what I will do is, I will draw a small block diagram. So let's say this is a programming block, our traditional program block, and this is the AI block. So what is the input that we take here? We take data as one input, and we also take rule or formula as another input, and then you write the program and you get what is called as output. This is our traditional program. Now in AI, what we do is, we give data, and we give expected output. Expected output. Getting it?
Yes, sir.
And we are hoping to generate rules or formula. Getting it? Now the point to note is the placement of these guys. If you are sleepy, then this is explicit pointer. Right? That is kind of exchanged. Getting it? That's the difference. So all that we do in AI, what do we do in AI? We try to come up with rules or formula. There is a fancy word for it, which is, we call it as model. If you come to my class, we will be referring to this as model all the time. Right? Model is nothing but mathematical formula. Getting it? So who gives the model? AI is not intelligent, okay? So designers of the AI systems give the model. So we, as the designers of AI system, have to tell AI what model we want to try. So let me explain that, okay? Any questions so far? Yes? By the way, I have an ability to look at face of a student and tell whether they have gotten it or not. Sorry, I cannot exercise this in front of camera in online teaching, but I'm really good at it. So I have a good model for that. So if you have any questions, please feel free to ask. No question is stupid question. If anyone laughs at your question, I'll ask counter question. Yeah, we used to have a teacher who used to say, asking question is very simple. Anyways, go ahead, one by one. Yes?
Like how AI and ML is related?
Okay, good question. Now people use it interchangeably, but we'll talk about that. Yes?
So,
No, sit down, sit down.
so if we get a model, it's a certain kind of Python code, or we get any kind of formula.
Very nice question. Wait for a few minutes. but thanks for asking that. Yes.
Can't we train the data without output?
Huh?
Can't we train the data without output?
You can do that, but you would not be able to detect whether there are humans or not. There is a specific type of that. That's a good observation. Sometimes you might get data without outputs. You can do some limited things with it, but we may not be able to solve the problem that I posed. Yes. Anyone else? There were so many hands raised. Now people have suddenly lost interest, or what happened? Yes.
So in the second diagram, first we will provide some data to the program and then it will learn from.
Yeah, data and output will be given together. We'll see. That's a AI process. Now let's go to your question. Whether model, what is model? Whether it's a Python code or what it is exactly, right? Any other questions? I'm going to move on. This will become a bit more complex. That's a warning. So if you have any questions, ask them right now. All right. So so what is this picture? What is this frame made up of? So there are pixels, right? So take a very simple thing, right? So let's say you have, I'm just making up some example, right? You have a grid like this. It's 6 by 6, right? It's 6 by 6 grid, and each point or each cell in the grid will have some specific value. Okay, let's say this is black and white. So there are only, it's a grayscale. So you will have, each pixel will have value between 0 to 255. Getting it? And you have 36 such kind of things, right? So we normally represent them like this. So we call this pixel as x1, right? Some other pixel, this pixel as x2, right? And so on. If I flatten it, if I open it up as an array, you will get, final one will be x36. Getting it? So given these 36 inputs, you want to know whether you will get, whether there is a human face or not. So we want to learn this mapping, right? So what kind of functions can you construct? So can machines construct functions or models or formulas? Probably hard, right? There are millions of functions, mathematical functions that we can come up with. So in order to make that task easier, what we do is, as a designer of a model, I specify the mathematical form of the model. So what is the simplest mathematical form? Yeah, y equal to mx plus c. What is that? Equation of straight line. Does anyone told you that you will be using this in AI?
No.
That's the tragedy. That's the tragedy of the maths that we learn, right? No one tells us that this will be useful for AI. And lots of AI is based on this simple thing, which is equation of, not equation of straight line exactly, but equation of hyperplanes. So line becomes plane in 3D, right? If you understand geometry, right? There is line in 2D, there is plane in 3D. What is in 4D? What do you have in 4D? Hyperplane. Hyperplanes. You have hyperplanes, right? So entire machine learning is all about learning hyperplanes. And what do you mean by learning hyperplanes? I will tell you in a minute. So now there are these 36 values, right? So we are dealing with data in 36 dimensions. So you will essentially have some kind of hyperplane, which is 36 dimensional hyperplane, right? So we write basically this formula. Let me use this ink. B plus W1 plus W2. I'll write this, okay? I have not completed this. W36, X1, X2, X36. Getting it? This is my model. This is my model. Huh? What is not known now in this? Weights are not known, right? And this bias I'm adding this bias because I don't want simply the hyperplanes that are passing through origin. I also need to be generalizable, right? So I want to admit all hyperplanes that are possible. So that's why I'm writing B, right? I'm using affine transformation. Huh? So far so good. So far so good. We are writing that. What is not known to us now? We do not know these 37 terms. Huh? And what is our job? Our job is to learn these 37 terms from the data that is given to us. How will you do that? Don't use these words. Say it in layman's term. Trial and error, good. So you start with some weights, right? They may not work well. Then you will do something, right? So trial and error will not be that efficient, correct? Because you will be searching all over the place.
Sir, we try with course elimination.
Okay, what does that do?
Sir, maybe we find the coefficients of this.
I see. Okay.
There are multiple.
Ah, I know. You will give answer. You have unfair advantage in this class. But you are right. I am glad that you remember that from the course. You have carried it over. Great. So we need a systematic method of searching in the space of weights. Okay. I won't be able to tell you now so many things because this is just 2 hours thing and we have to learn JAX. We are not there. We are just discussing about machine learning. So we have to learn these weights, 36 weights. So we will be learning these weights based on the training data that we have, right? So now, whatever weights that you use, right? What you want to make sure? You want to make sure that the labels that are coming out are as per the ones that are given to you. Getting it? And so we'll have to find out. So basically, what will happen is we start with, let's say, some random values, right? Random values of B, W1, W2 all the way up to WC, right? You can randomly initialize them. You can initialize all of them to 0, doesn't matter, right? Then what will happen is that substitute these values literally in this formula, and you already know the values of x1, x2 up to x36, right? So for each image, you will get a number. Getting it? You will get a number. On that we will decide some kind of a threshold. If number is above some threshold, we will call it as a human face. If it is below some threshold, it is not a human face. A very simple rule, right? So based on that, so you get prediction. So sorry, this is first step. Now we will repeat until convergence. So we will keep repeating this process. Okay, what will we do first? 2A, get predictions, and 2B, you will calculate how much loss or how many mistakes you are making, right? So if your parameter values are correct, you should make 0 mistakes. 0 mistakes is ideal world, right? Real world data it also comes with a lot of other complexities. So 0 mistake, but as little mistake as possible. Getting it? So get mistakes, and this, how do you calculate mistakes is what you define as again designer of a model, right? So there are so many things. We call it as AI. Machines are not at all intelligent, right? We are spoon feeding them. We are spoon feeding them with this formula. We are spoon feeding them with how to calculate mistakes. All that machine does is machine is good at running these loops, right? And then third step is based on these mistakes you will update weights, like B. You repeat. Now there has to be a principled way of updating this so that you make progress, right? If you do haphazard updating, things will not work, right? You might be able to stuck upon right weight just by chance. So all this will be taught in machine learning course. Okay, so there is a very systematic way of doing this. And by the way, what do we use here? We use application of derivatives. That's what we learned in standard 12. We use derivatives and applications of derivatives. So we calculate mistakes. So this mistake is a function. We calculate derivative of this mistake with respect to weights, right? And the point where the derivative will be 0 is the point where probably the error will be the least. Getting it? We use derivatives to find maxima and minimas of the function. Getting it? So all that we will study. So this is how you do it. This is the algorithm. This is the foundation of modern machine learning. Right? Now you take neural network, you take anything. What changes is just this model. This model is what will change. You take trees, you must have heard names, right? Neural networks. Somebody said YOLO. You said YOLO, right? YOLO uses convolutional neural network. Ultimately, it's a model like this, some such kind of a formula. So this is one component. So the first component is this. This is first component of machine learning. What is it called? Training data. Repeat after me. No data, no ML. No data, no ML, right? If somebody tells you that I'll do AI without data, meet him. Meet them for a coffee. Or lunch. Lunch is better. Yes, exactly. Right? No data, no ML. So training data is the first step. What is the second step? Model. What is the third step? The model or the function to calculate mistake. Formally this is called as loss function. And this procedure itself is a fourth component, not step. It's called optimization procedure. Getting it? And what do we get at the end of this? We get these weights. Then we go back. How do I go back? I have no idea. You guys are scroll down. No, thanks. Thanks. Yeah. We are here, right? So we get formula, correct? Now what you do is, you use this formula like a program. You put this formula here, you give data, you get output. So this is called as inference. It's called inference process. This is called as training process. So what is inference? Inference is as good as writing a program. Inference is as good as writing a program. Clear?
Yes, sir.
So now coming to your question, how does the model look like? Page up. So what do we code here? What do you write in program? You just code up this procedure that you see in front on the screen. We just code this procedure. Of course, we code how the mistake looks like. We also code how the model looks like. I'll show you one code. Okay? Sounds good? So you have to, this is very easy to code. Machine learning algorithms are very easy to code. What will it take to code this particular thing? It's just a multiplication and addition, right? But of course this will take time, so we vectorize it. Do you remember vector algebra? So third thing that nobody tells you that it will be useful. Sorry, I have suffered a lot, that's why I keep saying that. Every one of us gets suffered, yeah. I'll just write a very small equation so that it is easier. Right? Now you can actually write this as, I can write this as a vector, right? And this is another vector. This is actually a vector, this is actually a transpose. So I can say that this is W transpose X. Very sweet and short way of writing it. But this is nothing but this. So if you read machine learning books, you will see all these kind of things and people get scared. So in our course, we have tried to simplify it. We actually show you this, and then from here we show you this intermediate step, and then we bring to this. And then all that we do is we just implement this. In Python, this is one line of code. How do you write? np dot w comma x. Huh? Yeah, numpy arrays. This is numpy array, this is numpy array. So you say w is equal to np dot array, whatever, and x is equal to np dot array. Now this x can be anything. X need not be just single example. There could be, so you see this, right? This is like, what is the, let's look at this, right? Let's say n is number of examples and m is number of features. How many weights will be there? M plus 1, m plus 1, right? So now this will be 1 into m plus 1, correct? And x will be m plus 1 into n, right? With this single line, you are essentially able to generate a vector 1 into n. Now this is a bit harder for some people. Any question? Let me see. Any questions on this? Take a minute to process this. This part, when you do this, right, you will get output which is 1 into n. Which will you get? You will basically, huh? Yeah, n is number of examples, n is number of examples, and m is number of features. So this is one feature, this is another feature, right? So because we add one more of this, right, which is called bias. This one we add forcibly, just to make this vector calculation looking nice. Otherwise, sometimes I can also write this as W transpose X plus B. That is also fine. I can write this separately. B is bias. So we add that bias so that we just don't get hyperplanes that are passing through origin. If I set this B to 0, so see, let me not talk abstract. It's always good to talk concretely. This is equation of line. What is equation of this line? Y is equal to mx. C is set to 0. When I set C equal to 0, I'm only generating lines that are passing through origin, which may not be a good model for my data, right? Because I want to be general, right? So I want line like this, I want line like this also. That's why we add B. We have generalized it. By adding B, we are allowing all kinds of lines. In the same way, right, I am not good at drawing planes, but let us say y is equal to let us say b plus w1 x1 plus w2 x2. What is this equation? This is equation of a plane, isn't it? Equation of a plane. When I add b, I am allowing all planes that are not passing through origin. Also planes passing through origin by setting b equal to 0. Clear? Great. Any other questions? So I was telling you about vectorization, right? So W transpose X plus B. So now this particular code, right? This particular code can actually work on multiple rows of data. You can put in multiple examples. You can put in n examples, and still it will work, right? So for example, right? Let's take an example. My handwriting is better, but I am not used to this medium. Let me write it nicely. This is my weight vector. Weight vector ka transpose. This is W transpose. And let's say this is one example. 2, 3, 1, 4, 5, 1, 6, 8, right? So this is what is this? This is first example. This is second example, right? And this is third example. They are vectors, right? So this is B, this is W1, sorry, this is X1, this is X2. This bias, which is dummy column that I had, dummy row that I had. Now you do the calculation. So let us set this, right? This is 0, this is 1, this is minus 1. Do the calculation. Do the calculation by in your notebook. Do it. Don't do it in air. Do you have a notebook? Some of you do not have notebooks. It's good to do this calculation, I'll tell you. This looks very easy, but when you do it, it will stay in your head. I promise you that, right? So see, this will be one output. but do it. This will be second output and this will be third output. So resulting will be 3 numbers, right? Sorry, it won't be like this. You will get a number here, you will get a number here, and you will get a number here. 1 cross 3. This is 1 cross 3, this is 3 cross 3, you get 1 cross 3. Right? It's all 12 standard thing. That's what we do in machine learning. Whatever it is, I am not doing calculation. You do it. The reason I am asking you to do it is when you do it, this will stick in your head. It's of course very easy. You can figure that out. Clear? So the reason I am telling you this is that in JAX we are going to write a lot of such kind of vectorized operations, and in machine learning also we write a lot of these kind of vectorized operations. Clear? Yeah. Now I will do crowdsourcing and I will check whether things are correct because I am not doing calculation. What is your answer? Is this correct? Yes. Correct. I am using wisdom of crowd. I am hoping not everyone is colluding with you. That's the hope. That's why this particular thing works. And by the way, this is also one of the machine learning algorithms. This is also a machine learning algorithm because you see there is something called as wisdom of crowd. Crowdsourcing you use, right? So I give the same task to 10 different people and I assess that task based on what 10 different people are saying, right? And of course, assumption is that all of them are not colluding in the background. Anyways, great. So far so good? Huh? All right. So any questions? Why not? Let's go there. Sit down, sit down. This teaching is only available in offline mode, not in online mode. Online mode is too tough to teach. Yeah, tell me.
Here actually,
Huh.
W transpose no sir.
Huh.
The thing which you wrote there is the W transpose.
This is W
You
transpose.
are taking again transpose with.
No. Wait. Good question. See W looks like this. Wait. W looks like this. So by convention, a vector is always a column vector. By convention, it is a column vector, and since I am writing this like this, that's why I call it as transpose.
So why you take one of that?
That's the convention. That's what people follow always.
Sir, actually the page you wrote this horizontal vector and
You are right. Yeah. I got it. Thanks for pointing it out, man. Let's remove that. Let's remove the mistake. And let's call this as W transpose. This is X. Make sense? Thanks. Sometimes we also do intentional mistakes to see whether people are awake. Anyways, I had a manager who used to teach, and if he makes a mistake and if someone points at it, he says, yeah, I was doing it to check whether people are awake. So I just emulated it. Great. And yeah, exactly. Anyways, any other questions? No other questions? Can I access internet? But Amruta, do you know whether we have our collabs online? Yeah, I have one collab online. Yeah. No worries, I will get it. I will show you how to implement this thing. Okay, very easy. In another 10 minutes, and then I promise that I will teach you JAX. Okay. So you have contributed one of our collabs in this book, very famous book. Uh, what you see is our collab. Okay, we use this. So I will quickly show you the code. Let me see if I can run this in collab. Yeah, I will do that. Don't worry. No, I don't want to log in into this machine. Forget about it. Because I have phobia of logging in front of so many people. I have actually typed my password a couple of times in front of this audience. Since the yeah, I'm just sharing this, my embarrassments also. Right, I had done that couple of times and then I had to change all my passwords. So I don't want to do that again. Anyways, I'll increase the font totally. No. Is everyone able to see it in the back? Always ask the people who are in the back. That's one tip I would like to share. When you are teaching, always ask what the people in the extreme back think. Anyways, see, I am actually talking about a very simple model, first model, which is called linear regression model. And in regression, what happens is that we are trying to predict a number, right? So you are given inputs and you are trying to predict a number. So for example, what could be a good example that you could relate to it? So let's say you want to predict your mobile phone bill at the end of the month, and you have information about your usages, right? Different kind. It's a very simple thing, but imagine, and you want to learn the parameters. So the way, maybe this is a bad example, I don't know. Or let me come up with a better example, which we use all the time. Yeah, credit card bill, but I will use another example, okay, which is called, we call this as housing price prediction problem. Sorry for my students, they have heard it at the number of times. Forget about California, we say Madras housing price prediction. You can predict housing price anywhere, right? Or let's say time travel prediction problem, right? Travel time prediction problem. Time travel is difficult. You can do it, man. You guys are champions. You might make it possible. Travel time prediction problem. So let's say you want to figure out how much time will it take from IIT Madras to airport, or IIT Madras to railway station, or from place A to place B, right? So the prediction that you want is, sorry, he is my old buddy. He actually recorded a lot of my bad lectures. He, not by the way online BSc course, this is an NPTEL course. So why is the travel time, okay? I promise him that I don't give him any more bad lectures. Travel time prediction problem, right? What affects travel? Traffic, right? So maybe day of the week, time of the day, correct? And maybe other factors which I am not aware of, but whatever factors, mode of transport or whatever. And you want to predict the travel time. Good, man. What else? Whether it is festival or not, 1 or 0, right? So let's say these, yeah, let's say these are called features, right? And this is my label. So travel time is always in seconds or minute, whatever you can, minutes or hours. If you are from Mumbai, you will see, or in Bangalore, right? Bangalore is even worse. Anyways, travel time, correct? So it will be in hours or minutes. So you will get all these inputs and you want to predict the travel time in minutes. So what the model will learn? Model will learn weights, right? and those weights will basically be how important each of these factors are. Getting it? So, this is called regression problem. So, when y is a real number, we call this problem as regression problem. And regression is nothing but again learning the hyperplane. So, y is equal to b plus w1 x1 plus w2 x2. Here there are 5 of them, right? w2 x3 plus w4 x4 plus w5 x5, which I can compactly write this as w transpose x, or if I take this b inside, I can always write this as w transpose x. Clear? Okay, so this is the model xw. So, if I do for many examples, it is xw. This is a loss function. Loss function is basically the error that I make. xw is my prediction, y is actual label, actual value. So, we get error, right, and we take transpose of the error vector, multiply it with itself. This gives us squared error, right. And I will show you, I mean forget about all other things, I will show you how easy it is to write this code. I will teach you this whenever you come to my course next time. Huh? Online, yes. Yeah, this is part of machine learning techniques. This collab is part of machine learning techniques. I will show you. See, this is the class that I have written for. I will show you how it is very easy actually. This is a big collab actually. Combining all components. So, see, we have implemented this class. See how easy it is to write, how easy it is to implement machine learning techniques in Python. Yeah, you are hearing it for multiple times, sorry about that. Right, linreg, we are defining a predict function that gives us prediction, and this is a simple matrix vector multiplication. One line code, just one line code. The comments are more than that. Loss, mistake calculation, again couple of lines of code, right, and this is the fit function, and if you use slightly more involved method, iterative method, the way I have written it, right, it is hardly 10 lines of code, 5 to 6 lines. Okay, I will not explain this in detail, we will have chance to look at it when we do JAX. Okay, so it is so easy to write all these things. So anyway, we will do this when we meet in the class. Any questions so far? Any questions? No? Everyone is clear?
Sir, about the syntax, there was during the dot product there was a symbol at the rate.
At the rate is matrix product.
Okay.
Yeah, you can write np dot dot or you can write that at. It's a matrix product. So matrix vector product. Yes.
There is a request. Shall you elaborate the loss function in few minutes?
Sure.
Very easy.
No, we'll do that. We will definitely do it when we learn. Let me explain. No problem. Loss function is simple. Here we are saying that I'm getting a prediction, right? Prediction is what I get from the model. Whatever values of weight we set, we get a prediction. And then we take, this is the actual label, which is y, actual travel time is predicted travel time. If my weights are correct, what should happen? Actual and predicted should match. Ideally difference should be 0, but we want it as close as possible. Now this difference, does it make a difference whether this difference is positive and negative? No. So we actually square it up so that everything becomes positive. So that's why we take this transpose and we multiply it itself. So basically this is like squaring it up. This is a fancy way of saying we are squaring it up. Okay. All books write in a hard way. We are trying to really simplify it, right? So we are squaring it up. So we are taking square difference between the prediction and actual value. And how does this function look like? Square function. square difference. How does it look like? Anyone? Parabola, parabolic function, right? Like this. And this has got one minima, exactly one minima. That is called as convex functions. Good. And convex functions, if you have convex functions, then it's a very happy situation in machine learning.
So instead of squaring, we can just take absolute, right?
You can also take absolute. You get different kind of loss function. So it is your prerogative as a designer of this model what kind of loss function to use. But if you take absolute, what will happen? What kind of function do you? No, you get
Like line.
you get this kind of function,
Yeah.
and it is not differentiable here, right?
Yeah, right. At the vertex.
Yeah. So you have to basically take some special thing, right? So generally convex function differentiable functions are good. So if you can actually get your loss function to that, then life becomes easier, because now then you have to actually do the gradient calculations. Again, I am running too far ahead. It's good.
Why is there a half with the regions in?
Half we write for mathematical convenience. If I take derivative of this, right, I get basically derivative of x square is 2x. So this 2 and this 2 gets cancelled. That's the mathematical convenience. Okay? You have heard this. sorry guys. I actually teach, we have taught this in detail in the course. That's why some people who have taken course, this is repetition for them. I have not taught them anything for last 1 hour, which is bad. Anyways, any other questions? Okay, this was just a preview. Alright, so I hope you know now what is machine learning, right? And what are components? What are 5 components of machine learning? People who have taken my course are barred. I have talked about it at least 50 times in the course. What are the 5 components of machine learning model? 1, training data. Second, model. Good. Third, loss. Good. Fifth, I did not tell you. No, evaluation. We also need some kind of evaluation matrix. Once we have a model, right? How do you know whether our model is good or bad? See, you have to evaluate it, and if model is satisfying some, whatever is a business metric, then only we use that model in real life. Otherwise, we do not use that model in real life. That is called evaluation. Anyways. All right. So, any questions? What time is it now? 2 minutes. I give 2 minutes for asking any questions. At 3 we start jacks. As if 3 is a muhurtam. Yes? Any questions? No questions. Good. Is anybody feeling sleepy? I hope not. Slightly. I like your honesty. Okay, so we'll start with jacks. Do you know Numpy?
Yes, sir.
I don't know Numpy, man. You guys are far good. I'm bad at it. I'm not joking. I don't know Numpy. I know Numpy, but not extensively. So you know Numpy, right?
Sir, I don't know.
I'm here for that. What do we do? What do we use Numpy for? Yeah, basically mathematical computations, right? Vector matrix multiplication and whatnot. Okay. So do you know that we use accelerators for doing machine learning computations? What accelerators do we use? We use GPUs, we use TPUs. TPUs are. So why do we use accelerators?
Because they use parallel threading.
Yeah, but what do we parallelize?
The same matrix multiplication.
Matrix multiplication. So you now got the context how where the matrix multiplication comes in. Every machine learning model is some kind of vector matrix multiplication, and we can take advantage of GPUs for that. That's why we use these accelerators. So Numpy, in presence of accelerator, it will not exploit those accelerators. Even if there are accelerators, Numpy will not use them. Getting it? That's why we use jacks. Jacks exploits underlying accelerators. So jacks is Numpy. I'm making it uncool. JAX is NumPy with accelerators, with support on accelerators. Getting it? This is the first thing. JAX is NumPy, but you can say NumPy on steroids. Right? So, NumPy which can use these underlying hardware accelerators better. How, we will see. So, there are few things in JAX. So, one is basically the JAX generates random numbers bit differently than NumPy. So, it uses what is called a pseudo random number generator, PRNG. That is one thing. And why this is useful? Because we are going to run the code on multiple accelerators. For each accelerator, we JAX actually propagates that key and makes sure that things are reproducible. Second thing is, so underlying what JAX does is, JAX basically compiles your program in what is called as XLA, which is accelerated linear algebra. Okay, JAX internally compiles programs on what is called as XLA, and this XLA code is kind of can be run on any device, right? So let's not worry too much about it today. So JAX does it for the code every time it reads the code, right? So you can make it faster by caching this particular process. It is called as JIT, which is just-in-time computation. Right? So you can import JAX, and this is JAX.JIT. Right? So any function you can annotate it with @JIT. I can say definition add whatever, right? A comma B, right? And then whatever you write. So this function, first time when you call it, it will be cached, and every subsequent iteration will use this XLA converted version. It will not convert it again and again. So it shows up in the way this function would run. That's second thing. Third thing, some of you might get scared of vectorization, right? And vector matrix multiplication. Sometimes that is quite boring, right? So if you use JAX, you don't have to worry about vectorization. JAX automatically does vectorization for you, right? It has got a function called vmap. JAX.vmap. So if you generate a non-vectorized version of the function, and if you call JAX.vmap with that function as an argument, this is also another function, right? It returns the function which is vectorized version of the original function. Getting it? Fourth is a function called grad. So I was talking about this loss function, correct? And we were saying that loss function is convex and whatever. So what we need to do is, in order to implement the machine learning algorithm, we need to take derivative of this loss function. And if you use complex machine learning models, especially deep models, calculating loss function is a nightmare. It's very hard. So a lot of modern machine learning libraries, they come up with what is called as autograd. So JAX also has an autograd facility. It goes by the name grad. So you can use JAX.grad. So in JAX.grad, you just need to pass the function for which you want to calculate the gradient. And you can also specify with respect to which argument. So this is incredibly useful. And fifth thing is called pmap. If you want to parallelize the function on multiple devices, we use pmap. You don't have to do anything, it comes for free, right? So these are 5 important constructs, and then use NumPy. there is a library called, so you have to import jax.numpy at JNP. If you have a NumPy program, instead of NP you write JNP, program will compile and run. It need not be the most appropriate way to perform the business, but it works. Plus, if you create arrays in NumPy, you can use them in JAX code, that is okay. Okay, so JAX is a Python library which is like NumPy, but it can take advantage of the underlying accelerators. Right. For beginning, this is good enough to know. We will do some practice. Okay. VMAP, right? VMAP basically vectorizes the function. So, if you write, we had seen vectorization here, right? We said W transpose X. So, we vectorized it, right? Instead of that, you can write it in the way we had written earlier, W into W1 into X1 plus W2 into X2. You can write it that way. And if you say VMAP, it will get vectorized automatically, right? So, vectorized operations run very, very fast. That is another thing. So, you can do time it, and you can see that vectorized operation run way faster than non-vectorized operations. So, it is always recommended that all machine learning algorithms should be implemented in vectorized manner. Yes. Yeah, TensorFlow. Yeah. Yes. Sorry, I did not get your question. Hmm. No, so basically sometimes people find it hard to write vectorized versions. So, they can do the computation on a single example, but when it comes to doing it on multiple examples in a single command, people struggle, often struggle. For them VMAP is useful. Does that answer your question? You do not seem to be convinced. So, what is your question? Tell me. For VMAP? Okay, we will see that. You will have to hold on for some time. I have one example, I will show you that. Yes, anyone else? PMAP is for parallelizing. You will parallelize it on multiple devices without writing a single line of code. Yeah. Or whatever function you have written. By the way, JAX is not tied to machine learning. You might feel that JAX is tied to machine learning because we had so much of 1 hour of machine learning discussion. The reason I covered that is I want to actually take a couple of use cases which are concrete machine learning use cases, because that is what I know. I do not know anything else. I do not think so, because your vectorized implementation will take care of that, no? No, it does not matter, And by the way, JAX is more useful for reproducing state of the art research. So, if you see a new model written in a paper, using JAX it will be very easy to implement, because of all these things: JIT, VMAP, GRAD, these 3 things. Yeah. Yeah, JAX is very new thing. It is a very new library. We do not also know whether this will be used that commonly in by many people. We do not know. There is a lot of, I would say, tuck fight between different libraries. PyTorch seems to be right now at number 1. So, this is maybe TensorFlow's ways of racing back the market. I cannot say more than that. I have to say cut it. Anyways, got it? So, there is a reason why JAX. But I am not a PyTorch person, so I do not know, but I was told by people that even if you want to use PyTorch, you need to learn specific details of PyTorch. And I do not know what does that mean. TensorFlow I can tell you a bit. But JAX is like you can write everything in vectorized form, sorry, everything in Numpy style way, and then it works. Anyways, without further lecture, let's get into some action. I have a couple of codes that I have implemented in my laptop, which we will do it here. So where is JAX, right? So JAX documentation. This is JAX documentation. Okay. By the way, if you read through this documentation, you will get confused. I mean, I feel lost all the time when I read through this documentation, but I have told you the essence of it. Right? I have in fact written a small notebook which will be useful to run. For that, I will have to put my password. That's the only problem. I am a bit reluctant, but I will do it if need arises. We will do it. Can you see it? Can you see the no font is not good, no? Okay. Last person. You don't seem to be convinced about your own vision. You see it, no? Why are you confused? You see it or you don't see it? No problem. Huh? I am relying on you, that's why. You are my person. Okay, so if you have computers, you can open in Colab and run it so that you don't feel sleepy. This is a bit boring.
No Netflix.
No net? Okay, go home and then do it then. Sorry. So, see jax.numpy as this is not the best way of doing it, man. Let me put my password. All of you will close your eyes. Joking. Sorry, I am super paranoid about this particular thing.
Sir, can I ask something?
Yes.
Sir, what is the difference between CPU and
Yeah, good question. So, are you a gamer? Do you play online games? Yeah, it's okay. There is nothing bad, no taboo about that. So there are graphics card, right? So those graphic cards are there is something called GPU. So they are called GPU. So people use them for doing this machine learning computation. And TPUs, what they did is these graphic cards, whatever was not required for doing computation, they removed that, and they made a separate chip, which is 80 times faster than GPU. So TPU is made by Google. So this is at a very high level, I told you. So you can think of TPU as GPU plus plus. Getting it? So you need to pay extra money to get that graphic card. So there is NVIDIA graphic card. You put it, and then you can access it using a special programming language called CUDA. Now all that is really gone. Now people do it using all these kind of fancy things. Now you have TensorFlow, you have JAX, they have already wrapped it. And you just write code in TensorFlow, in JAX, even I guess PyTorch. And then it can use GPUs, TPUs that are available. Anyways, good, we are here. Yeah, thanks. Now I can do many things. I am in my playground. Yes. Yeah, I can do that. Let me see. I have written some code for this workshop. Again, it's not original written, I have just compiled it from the JAX thing. You want dark mode, right? Can you help me how to do that? Here, huh? Adaptive, dark. Developers feel at ease, no, when they see this. All right, let's do it. So I'll run this. Oh no, before that, few more stuff. Yeah, I have selected hardware accelerators. By the way, you get TPUs, GPUs for free on this Colab. You know that, right?
Yeah.
You can get, of course, you cannot run Colab instance for more than 12 hours, but for 12 hours you can get it.
So is there a way to run it in Bangalore?
Huh?
Is there a way to
You need to buy a Colab Pro for that. Yes. Sorry, I did not hear to DJ earlier. I am paying the price for that. Good. Last person. You are the person. Got it? So TPU I selected. I ran this command. So by default, JAX doesn't support TPU. So you need to write these 2 lines of code. You have to write jax.tools.colab TPU. You have to import this. Okay. Take some time. In between, do you have any questions? I also don't know. I don't know. We need to read that. We need to read that. We need to read that. I don't know complete details of this. Only thing is that this is better than Numpy. If you want to basically see, now what is happening is that our computation is happening on multiple devices. If there are multiple TPUs, different TPUs can run computations. Now because of the pseudo random number generator, I can actually generate many such kind of random numbers depending on number of tasks that I am doing, and that ability is not there in Numpy. Numpy you just get one seed, right, and you set that seed, but that seed does not guarantee me that it will be reproducible in such a distributed environment. So this much details I know, that is what I am sharing. Got it? So I generated random numbers here. Now this x, let us see what this x is. What do you think this x will be? Wow. Why? Then why was I seeing that? Previous one. See, x is called device array. So you can think of this as a promise. This is a placeholder, right? If you do this in Numpy, this x will be, you will actually see the array. Now these are device array. That is one of the difference. And in this device array, currently these values are stored. This array is stored. So this device array kind of tells you it's some kind of a placeholder on the underlying accelerators. That is one difference. So I am just telling you some very simple things, and I am hoping that you will carry them with you. Not telling you anything complex, and I also don't know too many complex things in JAX. I am also learning. Okay. So now you see this. So this time it will be very useful for all of us. Okay, because we want to compare how things work between JAX and Numpy. So we are doing random.normal, and now this random.normal, while we are doing it, we are sending, you are using key. Okay, that was generated through, I think we should write jax.random.normal. Okay. Now you see how much time, 5.49 millisecond per loop. Okay. And this was 3000 by 3000 matrix, and we actually multiplied that matrix with itself by computing the transpose. This is familiar to you, right? I need not explain all these things, right? X jnp dot x comma x transpose, read this as np dot x comma x transpose, and we use this block until ready, because what happens is that if I just time it the first part, it will time it the time it takes to put this x into the device. It does not give me the time that was needed to execute this particular command. So I have to use block until ready. When I say block until ready, this particular thing waits until the computation is available to me, until the result of computation is available to me. Then it becomes fair comparison. Okay. Now we will do the same thing with Numpy. I will show you. Let us look at compare the speed of execution between Numpy and jax.numpy. Again we are taking some long vector and we are performing a dot product. 1.53 milliseconds. Are you following me, everyone? I am not explaining details of Numpy. And now I am doing this with Numpy. Let us see. I think I need import. You see the difference? This is 1.53 milliseconds, 18.4 milliseconds, way faster. Said right, Numpy on steroids. The difference in speed up, right? So it has got JIT, grad and VMAP. Let's look at concrete use cases. Someone had you had a question, right? On VMAP. Let's look at that. Let's say this is some function, it's called Selu, some brother of Relu. Right? It does something, I don't know. So x greater than 0 is x, right? In Relu, this part is 0, but it is not, they are not making it exactly 0, but they are putting it some small number here. That is why I said brother of Relu. Now let us try to do this. We are running Selu, normal Selu, okay? 11.7 milliseconds. Okay? Pay attention to time right now. And these things are standard, right? This is some function that I implemented. I have timed it, and I am running it on a very large input. Now what we will do is we will do JIT, just in time computation. So now you have to, so JIT will take function as an input. So Selu was the function name, it takes it as an input and it returns another function, Selu underscore JIT. Clear? Very simple things, it is not rocket science. And now we will time it. So now when we time it this, let us see what happens. Unfortunately, all of you are not involved. This might be boring. You see the, right? You see the difference, 11.7 milliseconds, 1.51 milliseconds. Huge difference, right?
We can use decorator.
Yeah, you can also use decorator. So let us try that, no? So I have done that here. I have done that. Add JIT. So you can use a decorator. By the way, I never could understand reason for decoders when I first saw them in Java. I don't know what happens under the hood when decorators are written. I don't know. Can someone enlighten me on that? Because they seem very, I don't understand. I'm from pre-decorator era, from dinosaur era. I see. Okay, I see. What happens in Java 8? Same thing? No, I mean I am asking for Java 8. I don't know, I have seen the same thing in other languages. Sometimes this makes it a bit less transparent, no, to programmer. I mean, sometimes I find it very hard to read these programs and understand what is happening under the hood. I mean, if you look at read, of course, but they are for reason, because it might be easier to write program. But I think from, I don't know, do you have similar experience? I find it very hard to read programs with this. Yeah, and it becomes very hard, right? I mean, it is kind of non-intuitive what is happening. You have to put in more efforts. Yeah. Okay, let's try. I am hoping you will get similar speed ups. Yeah. 1.51 millisecond, 1.64 milliseconds are equivalent is what I will say. Right? Clear? You are seeing this? Okay, let's look at grads. Now this is linear regression function, right? Linear regression kind of function, right? X squared. We take x squared and we sum them. So this is a sum of squared, right? Now if you want to do sum of squared dx, so we use jax.grad. So when I say jax.grad and put sum of square, so we are able to get a derivative of the output with respect to x. And so you can see that. You can say you get sum of square is 30. Let us run all these things. Here the selling point is that you don't have to calculate grad yourself. Otherwise, you have to do this by hand. You have to implement another function that calculates gradient. Now this happens automatically, and this grad function is very powerful. It can calculate autograd for complex Python code as well, which has got loops, decisions. For that also, this grad calculates the gradient. Okay. Yes. It's very powerful. Yeah, you can do grad on grad. Second order derivative is also possible. Third order is also possible. Yeah, by the way, all these functions can be composed. You can do vmap, then on top of that you can do grad, whichever way. I have not reached to that level. Yeah, whenever I reach that level, I will teach. I will have another session. I am just sharing what I know so far. But that is possible. I have seen people writing that code. Okay, is this clear? I am just telling you very basic things, nothing complex. All this sounds magical, but this works. Okay. And okay, so if you have, let's say, couple of arguments, for example here, right, I have a function with two arguments x comma y, and we are taking a difference and then square of the difference. So now you can also specify gradient with respect to which arguments. So we can specify gradient argument numbers, and it will calculate gradients with respect to those argument numbers. Right. So you can see that there are device arrays with 2 rows, or 2 device arrays with 2 rows or 2 vectors. One is with respect to x, another one is with respect to y. Clear? No surprises, right?
So, one of the things I'm seeing with the target function here is that when comparing between Numpy and Jax, I'm consistently seeing that Numpy is more stable, as in the variance isn't high. So, how much of a difference does it actually make in real life, since Jax has higher variance?
Oh, that's a very good observation. But how did you come up with variance?
The slowest run to, I'm just assuming sort of like the variance, run to 315
That is in Jax.
Yeah.
Numpy we do not get that, right?
So in the previous one we get.
That's slowest one. Okay. Now this is JNP again. I think in Numpy we don't get that statistics. In Numpy we just said 10 loops best of 5. Yeah. But it's an interesting question. You should run this. No, seriously, it's an interesting question and good observation. Just run it and see. I'm sure that Jax will perform well. But somebody has to verify this, because we are all doing science. We cannot say that because instructor is saying so that is correct. No
But I
way.
think we can have percentage time as magic function, calculate the total time.
Yeah. I actually read somewhere why time it was taken. Instead of percentage time, there is a specific reason for which percentage time it is taken. I don't remember that exactly. All right. Clear? So far so good? I have not talked about vmap, but I will tell you vmap in context of something else. Okay. Any questions? We still have 30 minutes, 27 minutes. We will implement one machine learning algorithm. Okay, not regression, linear regression, we will implement logistic regression. Now, what is logistic regression? I need to tell you. Tell you in 5 minutes. We can also implement linear regression, but I am more comfortable, or I like the logistic regression code better. Okay, I will teach you logistic regression and then all of us will try to implement linear regression together. Okay, let's try that. We'll fail. Worst thing will be that we'll fail. It's okay. But we'll try together something.
Sir, I have one disease. Sir, you please explain that why the I am observing the linking. Many of the industry love logistic regression. I want a reason from you.
Sure. Why not? Logistic regression is the simplest of machine learning model, and it was workhorse of supervised learning for many industries. It was like, see, before deep learning era, logistic regression was used because it is simple, it is interpretable. That's why it was used multiple times. And one more thing that I teach in the class, if you are more curious about visual way of learning machine learning, try this particular thing as well. playground.tensorflow.com. Thanks. Somebody is awake. Is it correct now? Thanks. No, I have lost it. Why to do all these things? Just Google it. I'll show you magical machine learning. This is a classification problem. Points from two classes, blue and orange. Two features, x1 and x2. And this is that optimization stuff, right? Learning rate and things like that. So, we learned this model. This is logistic regression, right? We are able to find out one class from the other. Now here, this is fun. Just telling you in a minute. No matter how hard you try, you are not able to do this. You are not able to separate these two guys, right? Now I'll do some magic. What happened? Oh, my students are not allowed to. Not everyone is my student, but my ML students are not allowed to answer this question. What happened? What happened? No, I did not isolate it. What I? Huh?
If you are squaring both of them, then
I just added these three things, right? Yeah, I squared it. Yes.
you form, then it's x squared plus y squared equal to the radius squared.
Uh-huh.
So from there somehow you got that circle.
Nice. We are adding these higher order terms, right? Because these higher order terms, now I am no more just fitting lines. I am now fitting higher order polynomials. And I have the highest order polynomial is squared term, right? So that's why I am getting circular decision boundary, right? Now this is even fun. What is this called? Hyperbola. You are also able to fit hyperbola. Isn't it magical? See, representation is everything. The way you represent things, that's the crux, right? And logistic regression, the reason I came here, logistic regression, people were doing all these kind of polynomial transformation, second order, third order, fourth order, fifth order, and you represent the input in terms of very high dimensional vector, and then you apply logistic regression. Logistic regression was very powerful, stable. You can train logistic regression model with millions of features. It used to work. That's why it was used. It is not, it is no longer a story. Now people have moved to neural networks. But anyway, it's a good model to learn. All right. So what does logistic regression do? Is logistic regression, we know the linear regression, right? What do we do in linear regression? We calculate linear combination, which is b plus w1 x1 plus w2 x2. It's called linear combination. Now we take that linear combination and pass it to another function. It's called logistic function. Okay, now I have a board, so I don't have to talk. So how does this logistic function look like? I'll show you. It's a very interesting way. So there are two steps now. Okay, we need output which is either 0 or 1, or 1 and minus 1, or 0 or 1. So what I do is we do W transpose X plus B, this gives us real number. This gives us a real number. We pass it through another, it's called as transform, yes. And that transform should give us either 0 or 1. So, one such transform is called sigmoid transform. Do you know sigmoid function? Not my students. They know everything because
The number of COVID cases.
no, not something like it looks something like this. This is a very bad drawing, okay? Pardon me for that. This is 0, this is minus infinity, this is plus infinity. This is 1 and it crosses at 0.5, right? So, you take any real number and you can squash it between 0 and 1. Huh? As you go to the left of 0, as number becomes more and more negative, it tends to 0. If number become more and more positive, it tends to 1. And everything in between is between 0 to 1. Getting it? And then we draw a threshold at some point. Sorry, there is no undo, I hope. Okay. And then you set some threshold above which it is positive, below which it is negative. Huh? So, we take this, so we basically apply the sigmoid function on W transpose X plus B. This is logistic regression. Any questions? This is the model of logistic regression. Yes. Sigma is this function, the function that I have shown here. This is called sigmoid function. Depending on the value of this W transpose X plus B, you will get the output of the sigmoid function. It will be between 0 and 1. Getting it? This is the input, right? This is W transpose X plus B and this is sigmoid of W transpose X plus B. Clear?
Sir, why is it called logical?
Logistic regression.
Logistic regression.
This is also called as logistic function. Sigmoid function is also
But
called
it's a classification.
regression, right? The word regression confuses you. It's a historical nomenclature. Right? There is a regression style component here, which is W transpose X plus B. It's a linear combination, and you applied sigmoid on it. Maybe that's why people say it's logistic regression, but it's not a regression problem. It's a classification problem. Okay. All right. So let's try to implement this. Okay, in JAX. Now we import JAX. We import JAX.numpy j and p, grad. Forget about these two. We will not need these two. There is another way of solving logistic regression with Hessian matrix, which we do not have to bother about. Don't worry about these two imports. JIT random and map. Okay. We define this key. We get key, which is pseudo random number generator. Let me do this. Connect. We are not using TPUs here because we have not added those two lines, no. So we'll have to add them. Any questions? I am purposefully going slow so that you can process the information, right. In the videos it is not like that, we just keep talking. There is no way to slow down, but here we can do it. Let's see. And this is more human. Let's run this. I guess this will not work. Okay, now what is the objective of this? We will implement logistic regression using JAX. That is the only objective of showing this collab. Huh? Don't worry if you do not understand in and out of logistic regression, that is not expected. You do not know logistic regression. I just gave you some very high level overview. But what question will you ask me to know logistic regression better? What questions will you ask me? No. You are not allowed to talk. How do you understand any machine learning model? I told you something. Sorry to gag you. Something called as 5 components. Remember that, 5 components. Ask questions, what are those 5 components, and you will learn any machine learning algorithm. Literally, it's a magical key I am giving you. If you come across any machine learning algorithm, ask these 5 questions. What is the training data, what is the model, what is the loss function, what is optimization procedure, what is evaluation. You will understand this. Okay. Remember that. You will remember it anyways once you come to the class. Because I keep saying it in all the classes. Okay, so we are generating some training data with some 50 examples from one class, 50 examples from other class. Okay, so we have 100 total examples. What? Some problem? All right. There should be 100 examples, no? Why there are 50 examples? I'm concatenating all these things. Okay, I guess this is the problem. Huh? No? Why? Where is the issue? Shape is 50 comma, right? And then I am doing concatenation, so this should be 100, right? Feature matrix should be 100 by 2, correct? 50 and 50, concat 100, right?
We'll have to mention axis equal to 0.
You're right. Let us do it 25, 25 and see what happens. Original configuration. Where is 50, 2, 50, 2. Okay, let's come to fun part. This is standard thing we do, trend test split in machine learning, because we don't want to, we always want to report accuracies on the test set, right? Something which is not seen, right? Something which is seen I can always remember, and I can just mug up the answers and tell, right? If I give you only question bank containing 20 questions, you will prepare them well and come to the class. And if I ask you any of these questions, yes, 100%. That's called training on the same data, testing on the same data. Yes, that's why. Okay. All right, let's do it. Now I'm implementing some functions. Pre-activation is like linear combination. I'm taking feature vector. Is it a ring for us to finish? No, 15 more minutes. Feature vector into parameters, right? So I'm defining a dictionary containing 2 parameters, W and B. So we are performing multiplication plus addition, and we're doing JNP.sum. Then we are defining sigmoid function, which is we are calculating pre-activation passing through sigmoid. So we get number between 0 to 1. Now we are doing, see, this is VMAP. VMAP is coming here, right? So we are taking batch sigmoid. So this sigmoid is on a single data set. Now we are saying that run this sigmoid on multiple examples. So we have to specify in axis. So the first one ignore and take the second one. Okay. Now we will implement the prediction function. By the way, JIT is not useful for prediction function if it is used only once. If you are using again and again, then JIT makes sense. Otherwise, JIT does not make any sense. If something is being called only once, no point in calling JIT, right? But anyways, so we calculate batch, we call batch sigmoid, and we return. Here we have basically done binarization, right? We have to define a threshold. If the probability is above threshold, we are returning 1, otherwise we are returning 0. Sigmoid will return number between 0 to 1, right? It is also called as probability, right? And if this probability is above threshold, we are saying that this is positive, otherwise this is 0. So that's why JNP.1. Now this is the loss function. So loss function, now if you do not want to do vectorization yourself, you always implement, you should have this template, you should always implement loss per example. For a single example you implement a loss. So, you first calculate the value, correct. How do you implement loss? You have to get a prediction, you have to compare it with the prediction, with the actual value, correct. So, we are getting a prediction which is out and we are comparing this out with the actual labor. Now, there is a complex function here, forget about this. This is called as cross entropy loss. You do not need to know about it today. Okay, this is some function. Okay. So, now this function is implemented per example. I can make it work on multiple examples by calling vmap. I say vmap loss per example. I have a vectorized implementation of loss per examples. Then I calculate loss, which is I calculate loss per example and I do mean of that, take a mean of that. What is the average loss, right? That is how I implement loss. Now we go down and now again we are going to do autograd. So, we do not have to calculate the gradient of the loss function, correct. So, we have spent so much of time in our class explaining how to calculate gradient and derived it carefully. It is a good trait to have because you need to know how it is done and just not become slave of all these functions. So, but here it is simple, right, do grad, pass the function, you get the grad function. Life is easy, right, a big chunk of this process is being taken out. Now, we define optimization step, right. In optimization step what happens? We calculate the gradient and we update the parameter value. So, by the way, only one thing about JAX. JAX is functional programming. JAX follows what is called as functional programming. Okay, so some flexibility of Numpy is taken away. So, in Numpy we can liberally mutate arrays or input or something like that. JAX does not allow that. That we have to actually stay with that inflexibility in JAX. So, JAX define a structure called tree map. So, tree map is where is a structure, data structure that you can use to store any kind of values. Okay, all kinds of things you can store in tree map, and you have to basically use some function of tree map. So, PyTrees is the data structure, and map, you can think of map as a function that will be run on every single element of the data structure. So, we are doing tree map and we are defining a lambda function. So, what we are doing here is we are sending parameters and their gradients, and we are updating the parameters or weights by performing weight minus, so the existing value of the weight minus learning rate times the gradient. This is the standard function, do not ask me why, because you will learn that in machine learning. It will just take too much of time, we do not have that right now. And then this function will be called again and again, right. This is the master function or key function. This will be called again and again in the training loop. So, that is why we do JIT on this particular function. We have not done JIT on any other functions before. It is enough to do JIT on this master function, and this has got all other functions. So, all of them will be compiled. And now we have a standard training loop. So, we initialize parameters to 0, we define a learning rate, and then we are doing then we are running a loop where we are calling the opt step function, getting it, and we are getting the parameters back. By the way, some of these things will not be clear to you, but the point I am trying to demonstrate is the way we are using JAX functionality. Are you getting that point at least, everyone? We will run this also and see how things look like. Clear? Now, we will run this, run all. So, this is a model we learned finally. I am trying to also do something which is not yet working based on Hessian. That is there in this code, which does not work yet because of some of these issues in JAX. I need to use tree map, and how do you use tree map for Hessian is not very clear to me. So, I am trying to use that, it is failing. So, this is the boundary that we learned, by the way, so visual representation. So, we learned this boundary. So, you have some points that are misclassified. This point should have been here, but it is on the other side, and these points are also misclassified. But the point is that with this code we are able to learn this decision boundary. Questions? Yes.
Can you please explain what is an epoch?
Okay. Epoch is basically one full pass over training set. Whenever you make one full pass over training set, you we say that you completed one epoch. Now, why? So there is another way of training the machine learning models. Instead of using all the examples at once, we take small batches of examples and then update the parameter. Those are called as batch updates or batch gradient descent or batched. I am trying to avoid all kinds of terminology. We take batches of example. Now, in this kind of batches, you have to run this multiple times to complete one epoch. Let us say you have 100 examples and you are making batches of 10. You need to pass 10 batches to complete one epoch. So, long story short, one epoch is one full iteration on the training set. Yeah. Any other questions? Yes. Yeah, you can do that. Yes. Yeah, much simpler. So, that is why there are these two things which are jack forward and jack reverse. Forward mode differentiation, reverse mode differentiation. Yeah, JAX is basically a library that is made to make researchers' life simpler. All of us are researcher in this world, no, because there are so many new models that are being proposed and we want to implement them quickly. So, JAX is really good platform for that. But of course, there are in my experience, my limited experience of JAX, some of these things like some of these limitations of being immutable and other things, you need to get good mastery on PyT data structure and its manipulation. So, that's the key point. You cannot make changes, It follows functional programming. Yeah. Every time. So, see here, right? Here, I am actually getting the output, copying them into parameters, and then these parameters are being used again. Right? I am not passing these parameters and making them changes. So, in place updates, right, that we do is not happening. Yeah. So, this function is a pure function. It will not change anything that is passed to it. Getting it? It does not change anything that is passed to it. Yeah. It is not allowed. It is not allowed in JAX, and that is why we need to figure out how to use this tree data structure properly. That is one complexity. If we master this, then you can use this. Okay. So, what else? We are almost running out of time. Any questions? So, by the way, if you want to see this suspect, you need to be a bot. Tell me, guys. Where is boat? This guy is boat. 1, 2, 3, 4. Why this is not a boat? There is. प्रभु आप महान हो. This is wisdom of crowd. So now they know that we are definitely not bots. Good.
But they understood you are not machine.
You are interesting. See you in the live sessions. Anyways, it's good. I liked it. Yeah, see, this documentation is a bit too much to read, but now that you know bit of it, try to go through these tutorials. Working with PyTrees is, I would say, useful. but try all these tutorials. Best thing is to actually take, I mean, people who have done machine learning course already, take machine learning implementations and implement in JAX. In fact, I am trying to do that, so if you want to join my efforts, welcome. Let me know, drop me a note.
Are there any particular models where JAX is more useful
No, it is not like that.
than with
Yeah,
size
yeah.
of the data?
The size of data set is also not a problem because you can easily do PMAP and other things, right? So it doesn't matter, it works on
How
large.
do I decide if JAX is better or sklearn?
No, JAX is definitely better than sklearn, any days, any days. We are teaching you sklearn because it's a base library. It's a, yeah, yeah, yeah. All kinds of machine learning algorithm, all kinds of numerical computations. Like Numpy, yes. So whatever you can do with Numpy, you can do with JAX. Yeah, yeah, yeah. They are like they are machine learning algorithms, right? So you can implement, you can have JAX equivalent of that. But you have to implement those from scratch, no? Right. Huh? Yeah. Flax is better, yes. So JAX has an ecosystem. So LAX, there is something called as LAX, which is low level JAX. Then on JAX, on top of JAX is saying Flax. Flax is simpler. It's like, it will be easier to code in Flax. Huh? So you can actually, so there is some Keras like API in JAX. Somebody has created, last week I was reading that. You are the man. Thanks for hanging on that. Let's do it. It's okay, no problem. You are welcome to contact me anytime. I'm Ashish VT at gmail.com. I'm also Ashish_VT on Twitter. Yeah. On Twitter, I generally post about machine learning things. Okay. Before that, I'll address AI and ML. You asked that question, AI and machine learning? You only asked that question, or someone else asked that? Yeah, yeah, good. Why didn't you reminded me of that? Yeah, let's try that. Insert new page. Where is it? Right. You have time, right? Free, no? You want to go out? Yeah. Feel free to walk. Whoever wants to go out, I mean. This is a large circle. This circle is AI. It involves a lot of things. And small circle. This is ML. Yeah, these are subset of techniques that are used to achieve AI, but AI has lot more other things like planning and other things, right? Deep learning is here. Deep learning is nothing but machine learning, right? Neural network is also another algorithm like logistic regression. Ask 5 questions, you will get to know what is neural network, right? CNNs, which are used for image processing, are also another model.
So AI is just nothing but mathematics.
Huh?
AI is nothing just for mathematics.
No, not maths. AI is basically imparting human-like intelligence to the machine.
So, but you are saying these all are algorithms.
Yeah, they are all algorithms. So we are basically setting up the entire thing, right? I mean, how did you learn those parameters? We first set up the model, correct? We as a designer set up the model. And what did machines do? Machines are good at estimation. Machines are good at estimating those parameters given the data, right? So AI is, yeah, we use maths as a tool, but AI is not maths. Getting it? We use maths as a tool in AI. We use maths, we use stats, we use linear algebra, we use optimization. But never say that I learn AI by learning, after learning all these topics. Not happening. Getting it? This is the situation. There are many other things in AI. I do not know half of them. I'm not kidding. I only know there is planning or some such kind of things here. I don't know. Yes? Capture question? Right. Based on crowdsourcing. So basically what happens is that this is a task, right? They may not have ground truth for this. They will not have ground truth for this.
Is it reinforcement learning?
Not reinforcement learning. It's a wisdom of crowd. So basically what happens is that you are showing this image to many people and many people have clicked on that and said that it's a boat. Yeah, yeah, yeah. And it will have some rudimentary ways of saying which is not boat and things like that. For sure.
At the beginning, it would just, for the first set of people, it would be rudimentary. So it would
No, no, no. It will have some other checks for that. They'll show very different images or whatever.
So we are training the Google.
Yeah, yeah. All of us are training all AIs.
And we are not
Hmm?
we are data.
we are not paying.
Cut. Don't ask me uncomfortable questions. So, by the way, all AI is trained by all of us. Why AI is now powerful? I mean, what was, see all these ideas about AI, right? I mean, these are not new ideas. These ideas are there from 60s. So, what is causing this new revolution? Data and compute. Data and compute. And data is now, all of us are passionately generating data. Right, we are taking pictures, we are storing them on drives and whatnot, right? I mean, passionately generating data, which is good, bad. I don't want to get into debate. I am at least employed by that, so I'm okay. And all of you hope to get employed or whatever, right? So we have conflict of interest. Cannot comment on that. Yes. Yes.
I strongly feel that AI cannot replace all.
I
For
agree.
example, the way we answer. I was in the UK for 3 years. I know the way the British answer. Like for example, if they want to, like I'm not doing my work properly, they don't scold me.
Right.
They tell it in a very polite way,
Right.
but it equals to. That is their way of answering. Will AI be able to understand such things?
I hope not. No.
For example, I don't like a person. The way he answers. Then I'll say that the person is like a person, but I just repeat praising him. Without, like, okay, at the outset, it's like a praise. But actually, it's not. Only AI captures that.
If you give a lot of training data like this, then AI can certainly learn it. But not sentiment analysis exactly the way she's saying, right? I mean, you want to say something and you're saying it like that. So you need to prepare two pairs of data. This is what I'm saying and this actually means this, right? Or you mean to say this but you are saying it like this. So now you input, I want to say this, and AI will generate a polite response. But again, every task you have to do it like this, right? So it is like, it is definitely, I mean, currently, I mean, with all this hype and whatever, right? Not hype, I mean, we are actually seeing a lot of applications of AI. We are solving very narrow intelligence problem. So the tasks that humans are good at, the tasks that are repeatable, they are getting certainly replaced by, I mean, those tasks AI is able to do well. But there are certain other tasks which require higher level of cognition or whatever, right? Those tasks AI generally find it difficult to do. Right, and that will take some time. Artificial general intelligence, some people say that we have solved AGI, but we just need scale and more data. Yeah, many people, I mean, there is a Twitter chatter. Yeah, is what people are saying, but some other people disagree with that, no? Yes.
How to relate data science diagram?
Data science is plus management. You need to tell stories.
Tell a good story.
You need to be a storyteller to be a data scientist, right? And data scientist term is mostly used in other businesses, no, not in a tech company, right? In tech company, data scientist mean you are doing some product support, you are doing some support functions, right? In tech companies, people call it as ML engineer. So this management gets replaced by engineering. So here management means you need to basically talk with domain experts, understand the problem, right? Convert that into a data science or into a machine learning problem, correct? Solve it. then generate stories, go back and explain to them what it meant. In context of tech companies like Google, whatever, right, and Amazon, Microsoft, there are ML engineers. All they do is, there is a problem in the product that requires ML. They build data pipelines. You need to build data pipelines, bring in data. So by the way, the fun fact is that if you are doing ML in a product, ML is just 10 to 15% of work. Rest of the others is data. So if you want to be ML engineer, if you want to be ML engineer, if you say opening for ML engineer and apply, you might have to write data pipelines 80% of the times, which is not a bad job. I mean, I'm not complaining it, because see, I mean, it is unfair to people who are doing ETL. If you tell them that go build data pipelines and then I will just do that 10 to 15% of cream work, they can also do it, right, if you give them tools. So ML engineers have to do all these kind of things. Yes.
So, what do you think about that data science and psychology is closely related to each other?
I have no take on that because I don't understand psychology. I cannot. No, I'm being honest. I'm not making fun of his question. I do not know it. But how is that related? Psychology and data science? I don't know. Storytelling is not psychology, no. You have to be a good storyteller for sure. I don't know. Find out a context in which you read this. I cannot clearly think of anything like this. Yes.
Sir, in the Bombay, sir, there is a one story. मतलब एक ऐसा स्टोरी सर बहुत जगह एकदम हिट चलता है कि एक बार राकेश झुंझुनवाला सर
Maybe switch to English for being inclusive. Sorry.
So there is a Rakesh Jhunjhunwala sir and Damni sir in the party, and the Rakesh Jhunjhunwala sir saying to the Damni sir, to that यार मुझे AI से बहुत डर लगता है, fear from AI, because whenever I go to some create some kind of order, somebody already know what somebody tracing in the market. So sir, if the how sir AI become that much intelligent, they targeting the super people, we say the big people in the market, and they tracing what they tracking the actions, sir. Like that, and also sir, the Elon Musk also buy the Twitter. So sir, as an AI engineer, and sir, what
There are different parameters before that, so through that they are.
Yeah. Just a minute. Let me hear him out. Yes.
yes sir, like that, Elon Musk also buy the Twitter. One he also track some big giants in the world, like
Anyway, all of us are tracked anyways. All of us are tracked, and anybody can eliminate us because we are willfully giving all our data. We cannot stay with this device, right? I don't know. I mean, it's all about. But see, I mean, if I know what Rakesh Jhunjhunwala is doing, I may not be able to react to it, right? Unless I have some idea of how stock market goes, right?
sir, one more.
So there will be models that will be built. So data is definitely a key, right? I told you that no data, no ML.
Yes.
But just raw data does not have any value. You have to basically featureize it. Yeah. You're saying something?
They have different parameters so that they can present.
Yeah. But featureization is important, right? Raw data itself will not be useful. If I'm just getting sequence of signals.
They are active learning.
No, it's a feature engineering job. It's a very, I would say, not so cool job. It's a feature engineering job, but it's an important job.
So what is a cool job?
There is no definition of a cool job. I mean, it is all in our head. People feel that if I'm building a model, I'm doing something cool. But come on, I mean, somebody is giving features to you. If you go to Kaggle competitions, right, you will see that people winning Kaggle competitions do better feature engineering than others, right? So feature engineering is, I mean, it seems that it is not so interesting. All you are writing is program, right? Simple programs, simple transformations. But that's what helps, yes. So feature engineering is the most important step, and it is not taught that well in any of the course, I mean, because it's just too vast. Yes.
Feature engineering at 9th grade.
Is a?
This feature engineering that's like people especially
Because of deep learning.
because especially in terms of NLP, when you can feed anything to a bird model.
But look at this. Look at this. I'm a small business. I don't have budget to run BERT. What will you do?
then we consider running which technical and that is good.
So then there is a value, right?
But our software as a service,
I agree, but I believe that there is still a value, right? Because the thing is that if there is a trade-off that I need to do, let's say I don't want so great model that is giving 99% accuracy. I am okay to stay with 80% accuracy, but I don't have a lot of budget. So see, ultimately, right, I mean, there is not a single right or wrong answer, right? Sometimes we feel that this model has come in, so now everything will be, probably all these guys will be jobless or whatever, right? It doesn't work that way. So you have to, I mean, it changes from business situation to business situation. But sometimes people are okay, I am okay with 70% accuracy of the model, because anyway my people are just getting 30% accuracy. I mean, not because they are lazy or whatever, it's just the nature of the problem. But if simple AI, rudimentary AI is able to make it better, even logistic regression, why not use logistic regression? It actually gives you beautiful interpretability, why this model works. So that's why, you know, focusing on these models even in deep era makes a lot of sense. Other thing is, there are also environmental concerns about deep models, taking a lot of energy, electricity and whatever, right, being non-interpretable. Safety is also one of the concerns. So at that time, if you actually bring in a lot of such kind of domain expertise, better features to AI models, you don't have to actually train giant AI models. You can work with shallow deep learning models. Because see, deep learning, I mean, I know, I mean, I'm talking to you because, I mean, you may not be knowing deep learning, but deep learning, basically the power is coming through representation learning, right? And for learning that representation, we are putting layers and layers of neural net. If I replace this with some domain knowledge, maybe it is useful. So there is a value for that, a value in that, doing that is what I believe. Again, these are all my personal beliefs. And
How is legality of data usage? It's quite great.
it's a very difficult question actually. Yeah, some.
I'm doing TDS right now, and you know, one of the first things that they say is web scraping is not legal in many countries.
Yeah.
As a data scientist, how do you understand what data you can use?
So you should basically ask your legal departments. You have to always keep talking to your legal guys, asking them whether whatever you are doing is okay or not. Yeah, some big companies have actually very active legal departments, and they won't even allow you to access user data in its raw form. You have to basically write privacy documents, pages and pages of privacy document justifying why I need access to this particular user data. There are companies like that, but some other companies, everything is everything is up for grab.
But anything on the web is for grab, right?
No, it's not.
Not. Apparently, it is not.
But it's in the public domain.
It's in public domain, but it is for different consumption, right?
So the issue is it's hidden in the terms of service.
Yeah. Which we never read. Exactly. Anyway, we have gone massively over time. I'm okay. I can stay back, but I mean, if anyone wants to leave, feel free to leave. Okay.